Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is June 2026, and we are on the cusp. We are on the border of July 2026, and of course you know what that means. We have the 250th anniversary of our country happening this July, next month, and I have some special guests here who are going to help us celebrate that. So let me introduce to you Tristan, and welcome to the show, Tristan.
Thank you.
And then Parker, welcome to the show.
Thank you.
And you're welcome. And so Tristan is a member of our astronomy class at Belmont High School, and Parker is a member of our astronomy club at Belmont High School. And we have been working on a great project for America. And it's neat that our program is seen on cable TV shows literally from coast to coast. I think we're on 5 stations out in California. And it's just awesome to celebrate our country's 250th anniversary, literally nationwide. So we call this 250 Light Years of America. And again, this is with Belmont High School in New Hampshire. Astronomy club and astronomy class. So, Parker, let me start with you, if I may. What does this mean, this 250 light years of America? What is that even all about?
Well, our title, the 250 Light Years of America, is for one reason and one reason alone, that 250 light years ago, the stars that we're currently looking at least 2 of them, were roughly around the time that we gained our independence in America.
Yep. And Tristan, what would you have to add to that?
Honestly, it's giving me goosebumps right now, Mr. McDonald. It's crazy to think about that. These stars that we're looking at right now and that we're taking in, it's what they looked like when we gained our independence. It's honestly a crazy concept to me, and being here and being able to, witness and talk about it. I mean, I feel honored. It's
a great honor that we have to present this broadcast around the country. And the slide that you're looking at now is just an image of the Astronomy Club, and you can see what a great background, huh? The Declaration of Independence is right there, and members of the Astronomy Club with yours truly there as well. Well, why don't we get started? And the first star of our show is Spica in Virgo. Parker, what's something that you could tell us about the star Spica?
Well, out of all of them, Spica is one of the hottest stars that we are currently looking at, and its magnitude is around, visually, is 0.98 to 1.04, which is
very bright.
Pretty bright.
Yeah,
very bright.
And so, I mean, roughly all those numbers, it kind of averages to a 1.
Yeah.
And as you look at the screen here, you can see my red laser dot. And just to review, how do you find Spica? Well, we're facing south here, and if you find the Big Dipper, which at this time, which is in the vicinity of about 9:30, and we just chose the middle of June, so this is like June 15th, 9:30 in the evening. And close to an overhead position, you find the Big Dipper. And you find the Big Dipper, and notice the handle of the Big Dipper creates like an arc. And so we arc to Arcturus, and that brings us down to this really bright reddish star, Arcturus, and then we spike down to Spica. And Spica, as Parker said, is very, very hot. It's a blue star. And this star that kind of connects the handle to the dipper part of the dipper is white. And so I think it's really kind of awesome that right here, looking up at the night sky, we have a red star, Arcturus, a white star, Alioth, and we have Spica, which is a blue star. And so we arc to Arcturus, and we spike down to Spica, which is close to the horizon as you face south. Tristan, maybe you could share a couple other fun facts about Spica.
Sure. So, Spica is actually the 16th brightest star in our night sky. The star Spica isn't just one star. It's two stars. It's a binary star system. And they're so close together, they're about 11 million miles apart, or 18 million kilometers, that they kind of form an egg shape and kind of warp each other. And its absolute magnitude is negative 3.55. Now, keep in mind, this value represents how bright the star is at around 10 parsecs away, which is 32.6 light years. And that's not very bright. Actually, that is very bright.
That's very bright.
That is very bright. Way brighter.
It's a way bright star.
Oh, yeah.
And as you pointed out, that's just so true. And if you look at this slide here, you see that Spica is part of the constellation of Virgo that we mentioned. And what is the significance, Tristan? You remember what the significance of Spica is in relationship to Virgo, the Virgin? What part of the constellation does Spica represent? Kind of looks like a sheaf of wheat there.
Yeah, it does.
Yep.
The name Spica comes from Latin and means ear of grain, because Spica actually represents wheat held by Virgo.
Yeah. And also, about how many light years away is it?
250 light years.
250 light years. And what does that mean, Parker?
About 250 light years ago, that is when originally that light started traveling towards Earth and then finally reached us. And now, 250 years later, where we are now, we're finally seeing that light that was made 250 light years ago, which is pretty cool, in my opinion, at least.
Yeah. And so we have, that's really an amazing thing. And as you mentioned, Tristan, 18 million miles apart for two stars.
Kilometers. 18 million kilometers.
Right, 18 and right. And so 11 million miles, and that is really close. I mean, you think about the planet Mercury, and the planet Mercury itself is like 27 million miles from the sun. Earth is 93 million miles from the sun. And here we have two stars, two suns, basically, only 11 million miles apart. It's craziness.
And a little fun fact, if you don't mind me adding, you can't see it with a telescope, but, I mean, they're like two balls right next to each other, and then they're kind of warping little bit into each other, forming an egg shape, like I mentioned earlier.
And so, and can you perceive that egg shape through a telescope, maybe if you had enough power?
I don't think you could. I mean, maybe with a powerful enough telescope, maybe. But so far with the technology that we have not been able to identify that egg shape.
Yeah. But we know because of gravity, its closeness, and the gravity just causes that to happen. So let's take on our next star. So that's Spica, very easy to find in the night sky. Next on the show is going to be Kujam in the constellation of Hercules. And Kujam in the constellation of Hercules is on a dimmer side, but it, I think, is a good project to go out and to find it, because Kujam, Parker, is about how many light years away?
Kujam is about 235 to 250 light years away from Earth, which is, again, about close to roughly when we gained our independence.
That's right. So again, there's that number, 250 years ago. So as you look at this star chart that you see in front of you now, we know how to find Arcturus, right? Because up above is where the Big Dipper is, but we needed to zoom in a little bit here. So you find Arcturus and you spike down to Spica, we're good. But near an overhead position is the brightest star for the summer sky, which is just gaining prominence now in June, is the star Vega. So you see up in the upper left of your screen, the star Vega, which is very bright at a magnitude 0, and Spica is a magnitude 1, and Arcturus is also at a magnitude 0. Well, if you made a line from Arcturus up to Vega, kind of in the area closer to Vega, you can see this kind of, I think it looks like an H shape, H for Hercules. And the star that we're looking at, Kujam, is over here, is Hercules. Can you see that H shape? It kind of crosses here. And right off of Vega is where we see it. And then I have it circled here. So you have the constellation of Hercules right here. There's that H shape. And that's one of his arms coming over. And then there's a star off the edge of his arm that I have circled there. And that is the star Kujam. And so, Tristan, why don't you give us a couple of fun facts about Kujam?
Sure. So another name for Kujam is Omega Herculis, which, by the name, well, you got your Greek letter Omega and Hercules following Hercules. Sorry, it can be seen under the naked eye in fairly nice conditions.
Yeah, it's on the dim side at about 4.5 magnitude, and we have talked about before that magnitude 6, the higher the number, the dimmer the object or the dimmer the star. And a magnitude 6 is typically at the limit of human visibility if it is really dark in ideal conditions. So we're at about a magnitude 4.5. Each magnitude is about 2.5 times brighter or dimmer than the magnitude before it. So 4.5 is doable if the conditions are right and if it's clear enough and dark enough to be able to see it. And so Kujam, again, we're in the 250 light year ballpark. So I would encourage you, take another look at our star chart here. As you see this H shape over here, right off of Vega, and then you come across the top of Hercules and keep on going. You come to a dim star, but it's perceivable, and I think it's a nice challenge to be able to find it. And that is going to be Kujam, 250-ish light years away. Kind of cool. Okay. Next, we have another star. This is our third star that we'll be talking about on this show, and it's Xenia. We already talked about the constellation of Virgo, the Virgin, where Spica is located. And in that same constellation, we have Xenia. It's hard to find stars that are right in the realm of 250 light years apart. And we obviously want to find stars that are 250 light years away that you can see in the night sky. There's other stars, but they're in the winter sky or they're in the fall sky. But we want things that you can go out and see in June and July. So Virgo is a very prominent constellation for June and July. So we thought we'd see if there's another star there. And Xenia is in fact there. So as you see with my red laser dot here, remember Spica. Spica is kind of like, has been like an anchor for us to be able to find things. So the Big Dipper again is overhead. We use the handle of the Big Dipper. We arc to Arcturus, spike down to Spica, which, as Tristan pointed out, is that sheaf of wheat in her left hand. And then we come up and take just a very slight right turn, if you will. And right there, that's Xenia. And so once again, Tristan, maybe you can tell us a couple of interesting facts about Xenia.
Sure. I'll tell you about the origin, actually.
Okay.
The origin of the name Xenia comes from Arabic, and it translates roughly to the corner or angle. Its absolute magnitude is around -1.1, which I'd say is pretty bright, and its visual magnitude is around 3.89. It's much farther away than many bright stars seen in the sky, but guess how far away it is?
I bet Parker could tell us. How far away is it? What's the magic number?
Well, the magic number would happen to be 250.
It is.
It is
250 light years away. Who knew? Who would have guessed? And so my guests have guessed, and it has been really awesome talking about these three stars. Now, obviously, this is June. July is coming up, and for our July show, we'll have a couple more stars 250 light years or so away to be able to share with you on the July show. We want to keep this thing going because we have a great celebration of our country, and this is, in fact, 250 light years of America with Belmont High School Astronomy Club, and there is more to come in July. Craziness. You notice behind us there is the Stonehenge Monument, and the Stonehenge Monument is in England and outside of London a bit, and so it has some particular significance when we get to the solstice, whether it's the winter solstice or the summer solstice. So our summer solstice this year is going to be June 21st, 2026, and that's 4:24 Eastern Daylight Time, and that's AM. That's in the morning, 4:24 Eastern Daylight Time. And I know that Tristan has a few things to share about Stonehenge. So take it away, Tristan.
So first I want to talk about the summer solstice and what a summer solstice is. Every year around June 20th or 21st, the Northern Hemisphere experiences the summer solstice, which is the longest day of the year. This causes Earth to tilt. The Northern Hemisphere is closer to the sun, and it causes the sun to appear higher up in the sky. And a little bit of background on solstice and what it means is it comes from the Latin word solstium.
Who knew?
Who knew? I didn't know that. So solstium combines sol, which is our sun. Sol is the name of our sun. Sorry, let me make that correction. And sistere, which means to stand still. into sun stop. So solstice means sol, sun, stop, stis. And now one of the most famous places connected to the summer solstice is, well, Stonehenge. Stonehenge is a prehistoric stone monument built thousands of years ago, as you may know. During the summer solstice at Stonehenge, the sun rises perfectly in alignment in between, wrong side, sorry, in between these rocks here. It's a possibility builders who made Stonehenge knew astronomy and could have likely done it on purpose. That is the best way I could put that.
I would agree. I mean, how else could you put it? It clearly was purposely done. Those stones have been brought for miles and miles and miles. And there's the blue stones, which are not shown in most of the images that you would see. These big monolithic stones, if you will. And so we have just an amazing astronomical monument made that seems to connect with the summer solstice and the winter solstice. So,
which, to be honest, if I could add something there, I think that's incredible.
It really is.
How do people come up with this? 5,000, around 5,000 years ago. How did people come up with this? It's crazy to me.
And kind of as a side note, as you say, people coming up with this, we mentioned the pyramids. And the pyramids have some mystical, if you will, alignments with the astronomical events during the year as well.
Really?
And so that's kind of cool.
Nice.
So as Tristan mentioned about solstice, if you look at this chart here, you see the equator, which runs through the top part of South America and kind of through the central part of Africa there. But then you see the Tropic of Cancer. And what makes it the Tropic of Cancer is that's where the sun stops 23.5 degrees north of the equator. The tilt of Earth's axis is 23.5 degrees. And back when this was figured out and these tropics were named, on the solstice, the sun was in guess what constellation?
Cancer.
Yeah, in Cancer. And that's why it's called the Tropic of Cancer, because that's where the sun was when the summer solstice happened. Now, due to a phenomenon called precession, and we're not going to get into that in this show, but things are off and are a little bit different. So on June 21st at 4:24 a.m. Eastern Daylight Time, the sun is going to, if you will, just touch or kiss the Tropic of Cancer, and then it will start on its journey southward, crossing the equator on the equinox, and then heading down to the Tropic of Capricorn, where it will just touch that line, imaginary line, 23.5 degrees south of the equator on the winter solstice. Pretty cool, fun stuff. Well, I want to thank both Tristan and Parker for coming. Tristan, thank you for being with us. Parker, thank you so much for being with us on the show and helping us to understand these stars 250 light years away, representing the time when our country gained its independence. Craziness. So again, thank you for joining us. And we're going to take a look now at the night sky and see where we can find some planets in June. So check this out. I hope you enjoyed that chat with Parker and Tristan. It's great having my astronomy club, astronomy class students here talking about the amazing 250-year anniversary we have of our country. Now, just before I tell you about the planets coming up, I want to let you know about what's going on June 5th at the McCall Shepherd Discovery Center. That's Friday night. And we are having Cosmic Time Capsules, the story of meteorites. That's June 5th. This is 2 Institute Drive, Concord, New Hampshire. And 6:30 is when the doors open. The program starts at 7 o'clock. We have a Tonight Sky show. The New Hampshire Astronomical Society will be there with telescopes of all sizes and all sorts of things. But you don't want to miss the story, the Cosmic Time Capsules and the story of meteorites, okay? Don't miss that. Now let me tell you, June 8th to 10th, after sunset, around 9:15 or so in the evening, you got June 8, 9, 10. Hopefully one of those nights will be clear. And look what you can see. You've got the planet Venus and the planet Jupiter right so close to each other. And this happens to be June 10th. June 8th, you're going to have Venus down a little lower, and then getting up a little higher on the 9th. And where it is right here, this happens to be a snapshot of the way it's going to be on June 10th. And notice also, hiding behind this tree here, I couldn't get rid of the tree. My shubmaster couldn't come and chop it down. But anyway, Mercury is also in the sky. And so that's kind of neat as well to have Mercury there. But looking at the conjunction, we call it, of Jupiter and Venus is really going to be pretty neat. So don't miss that. And then on June 10th in the morning, we have another great treat happening. Before the sun is up, we have the moon and Saturn. And I noted in the upper left there that the moon is crescent, because when you look at the image here, it looks like it's a full moon, and it's not. It's a slender crescent moon, and it is what we call a waning crescent moon. And it's hanging out by Saturn, and that's going to be very pretty. And then we have the planet Mars, pretty close to the horizon. The east-northeastern horizon is where you're going to find the planet Mars. So that's going to be a nice morning to take pictures as well. And every morning after June 10th, the moon is going to be moving towards Mars, but it is going to be less and less crescenty, or less and less lit up as that time moves on. So there's a couple of great things you can see. June 8, 9, 10 in the evening after sunset, you've got Jupiter and Venus hanging out. And then in the morning, June 10th, is when the moon is going to be near Saturn, but you've got days on either side of June 10th. Mars will be available in the sky, and Saturn will be available in the sky as well. And those of you who want to get up maybe a tad earlier may notice that the Andromeda Galaxy is visible, and you can check out where you can find that. And that is going to be off of the square of Pegasus. We have the constellation of Andromeda, and the Andromeda Galaxy is available. And you want to get that a little sooner, maybe 2 o'clock, 3 o'clock in the morning, before the sky starts getting light. All kinds of things to see. And then next slide, as we finish up here, we want to bring you what we're seeing in the next slide, 250 light years of America, Belmont High School. And we've got it. I'll step off here. Belmont High School in New Hampshire, the Astronomy Club, Astronomy class. And we hope that you enjoyed the show. And don't forget to tune in again in July, when we'll be showing you some more stars. So I'm Dave McDonald for The Sky This Month. And please feel free to give me a little note, an email, astromannh@gmail.com. And I'd love to answer your question, or maybe we have something that you would like to see on a future show. So Dave McDonald for The Sky This Month. Don't forget to keep looking up.